Now, in this lecture, we are going to continue the examples in the miscellaneous exercise 7. 5 examples are done. Now, the example number 6. A fair coin tossed 4 times. Let x denote number of heads obtained. Write down the probability distribution of x and also find the formula for the PMF of x. Okay, here. This question we have already learned in our exercise 7.1 and our video lecture number 5. Okay, but here the extra question asked, also write the formula for the PMF. Okay, first we find the probability distribution and then write the formula for this probability. Okay, here a coin is tossed 4 times. Here the experiment is a coin is tossed 4 times. That means there are the 16 possibilities. When 2 coins are tossed, 4 possibilities. When 3 coins are tossed, there are the 8 possibilities. Now here the coin is tossed 4 times or 4 coins are tossed, that are the 16 possibilities. Here a coin is tossed 4 times, therefore the all possibilities, here we can write it is yes. Total possibility is first possibility, all are the heads, H, all are the heads. Okay, then second possibility, 3 heads and 1 tail, it is H and T. Okay, here, but here 4 heads, all are the heads, but here 3 head and 1 tail, but the position of the tail, it is a 1 tail, it is a on the 4th toss, 3rd toss, 2nd toss or the 1st toss. There are the 4 possibilities of the 3 heads and 1 tail. Here we write the tail on the 4th toss, either tail or in the 2nd toss, 3rd toss or 1st toss. Here it is H, T, H, then H, T, H and T, H. Okay, see carefully this. Okay, here it is a 4 heads, now 3 heads and 1 tail, because a coin is tossed 4 times, therefore all are heads, it is the first possibility. Then next 4 possibilities, 3 heads and 1 tail. Now 4 head, 3 head, now 2 heads, therefore here H, 2 heads, therefore remaining 2 are the tails. Okay, H, T. Okay, now 2 heads and 2 tails. A coin is tossed 4 times and 2 heads and 2 tails. There are the 2 heads, 2 tails, and 4 coin is tossed 4 times. That means 4C2, the combination. There are the 6 possibilities. But here we write the first 3 possibilities. Here it is the first possibility. Then we write this head on the 3rd toss. We write this head on the 2nd toss and this head on the 1st toss. Okay. Therefore, it is a H, T, the 4th toss T as it is. Then T, H, T. See carefully this. These are the 8 possibilities. Okay. Then here 2 heads, 2 tail, 2 head, 2 tail, 2 heads, 2 tail. But there are the 6 possibilities. We write only 3 possibilities. Okay, the remaining 3 possibilities we can write, but here the total possibilities are 16. Okay, in the first row we write the 8 possibility and remaining 8 possibility we write by using the technique. Okay, here 4 heads, 3 heads, 1 tail. Here 2 head, 2 tail, but here write only the 3 possibilities. Okay, remaining 3 we write here in the below. Now these are the 8 possibilities. Remaining 8 possibilities we can write replace head by tail and tail by head. Therefore we can write here tail. Here tail, and it is a head. T and it is H. T. Only replace head by tail and tail by head. Then here T. H, T. Here it is T. H, and it is H. Okay, see carefully, these are the 16 possibilities. Okay, here 4 heads, there is 1 possibility. 3 heads and 1 tail, there are the 4 possibilities. 2 heads and 2 tails, there are the 6 possibilities. 1, 2, 3, 4, 5 and 6. 3 head, 3 tail, 1 head, there are the 3, it is 4 possibility and all are the tails. that is the one possibility. Okay, here these are the 16 possibilities. Okay, here a coin is tossed 4 times. तर सॅम्पल स्पेस लिहायसाठी एक टेक्निक व्यवस्थित पहा. ओके, सॅम्पल स्पेस लिहिण्यासाठी काय करणार, सगळ्यात आधी 4 हेड्स. ओके, 4 हेड, त्याच्यानंतर 3 हेड्स अँड 1 टेल, कारण आपल्याला अ कॉइन इज टॉस्ड 4 टाइम्स म्हणजे 4 आउटकम मिळणार. ओके, एच टी, त्याच्यातले 3 हेड आणि 1 टेल आहे. तर काय केले, टेल. मग टेलची पोझिशन काय, एक तर 4th टॉसला असेल, 2nd टॉसला असेल, 3rd ला असेल किंवा 1st ला असेल. तर काय केले आपण, हिअर आधी 4th ला होतं, नंतर 1 ने इकडे सरकवला, नंतर पुन्हा 1 ने इकडे सरकवला आणि पुन्हा 1 ने इकडे, एकदम फर्स्टपर्यंत आलं. ह्या झाल्या तुमच्या 4 पॉसिबिलिटीज. कशाच्या, 3 हेड अँड 1 टेल. त्याच्यानंतर 2 हेड अँड 2 टेल, 2 हेड 2 टेल, पुन्हा इथं तेच केले, 1 टी इकडे सरकवलं ह्या टीनं, हेअर इथं घेतलं, त्याच्यानंतर इकडे घेतलं. ओके, ह्या झाल्या 3 पॉसिबिलिटीज. मग जेव्हा तुम्हाला 16 पॉसिबिलिटी लिहायच्या तेव्हा काय करायचं, पहिल्या रोमध्ये 8 पॉसिबिलिटी लिहा आणि 8 पॉसिबिलिटी कोणत्या वेळेनं, 4 हेड्स, नंतर 3 हेड 1 टेल. ओके, 3 हेड 1 टेल, 3 हेड 1 टेलच्या 4 पॉसिबिलिटी. त्याच्यानंतर 2 हेड 2 टेल, तर 2 हेड 2 टेलमध्ये काय, लास्टचं टेल फिक्स ठेवा, या टेलची जागा बदला. 3rd टॉसला जे येते, 3rdचं 2ndवर आणा, 2ndचं 1stवर आणा, 3rdचं 2ndवर आणलं आणि पुन्हा 2ndचं 1stवर. ह्या झाल्या 8 पॉसिबिलिटी झाल्या की नंतर काय करा, डायरेक्टच लिहा, रिप्लेस करा. हेडच्या जागेवर टेल, टेलच्या जागेवर हेड. ह्या झाल्या तुमच्या टोटल 16 पॉसिबिलिटी. आणि डायरेक्ट वेनं जायचं म्हणलं तर काय, 4 हेड, नंतर 3 हेड 1 टेल, त्याच्यानंतर 2 हेड 2 टेल. मग याच्या 6 पॉसिबिलिटी. याच्या 6 पॉसिबिलिटी कशा लिहिल्या, हे इकडे सरकवलं 1 1 नं, नंतर आता हे लास्टचं टी फिक्स ठेवलं होतं, त्या टीला पुन्हा इकडे सरकवणार, या टीला इथं घ्या, पुन्हा इथं घ्या, ह्या 2 पॉसिबिलिटी येतात आणि पुन्हा ही 1 पॉसिबिलिटी. ह्या झाल्या तुमच्या 6 पॉसिबिलिटी, म्हणजे 2 हेड 2 टेल. त्याच्यानंतर 1 हेड 3 टेल, पुन्हा 1 हेड अँड 3 टेल्स, त्याच्या पुन्हा 4 पॉसिबिलिटी. 1 हेड, मग हेड एक तर 1st टॉसला असेल, 2ndला, 3rdला किंवा 4thला असेल. हिअर 1st टॉस, 2nd टॉस, 3rd टॉस आणि 4th टॉस हेड. आणि नो हेड ही झाली पॉसिबिलिटी. ओके, पण ही 16च्या 16 लक्षात ठेवायला, ही टेक्निक लक्षात राहू द्या. सुरुवातीला 8 लिहा, 8 कसे लिहायचे तेवढं पहा. 4 हेड, नंतर 3 हेड 1 टेल, त्याच्या 4 पॉसिबिलिटी, नंतर 2 हेड 2 टेल, त्याच्या 6 पॉसिबिलिटी आहेत, पण 3च लिहा वर, म्हणजे टोटल वर लिहा 8 आणि नंतर फक्त त्याला इंटरचेंज करा. ओके, हेडच्या जागेवर टेल आणि टेलच्या जागेवर हेड. ओके, हे झाले तुमचे टोटल नंबर्स. देअरफॉर नंबर ऑफ यस इज इक्वल टू 16. ओके, नाव यक्स काय, हिअर द रँडम व्हेरिएबल यक्स इज नंबर ऑफ हेड्स. Number of heads. Okay, when a coin is tossed 4 times, therefore random variable takes values. Random variable x takes values. Okay, see carefully. Random variable takes values. X is a number of head, so we count the number of head in each outcome. Here, in the first outcome, there are the 4 heads. It is 3, 3, 3. Here again 3. Here 2 heads. Here 2 heads. Here 2 heads. It is a 2 head, 2 head, 2 head. Here 1 head, 1 head. Here 1, here 1, and here it is a 0 head. That means random variable x takes value 0, 1, 2, 3 or 4. Okay. Here it is a 0, 1, 2, 3 and 4. Okay, now we want to find the probability distribution of this random variable. When x is equal to 0, here x is equal to 0, that is number of heads 0, there are 1 time, therefore the probability is 1 by 16. When x is equal to 0, that means 1 head is a 4 times, that means the probability of x is equal to 1, it is a 4 by 16. 2 heads, there are the 6 times, then again the probability of x is equal to 2, it is a 6 by 16. Okay, we write the probability distribution. Now therefore number of x is equal to 0, number of x is equal to 0, it is 1, therefore probability of x is equal to 0, it is 1 by 16. See carefully. Number of x is equal to 1, it is x is equal to 1, 1, 2, 3 and 4, it is a 4 times, therefore probability of x is equal to 1, it is a 4 by 16. Then number of x is equal to 2. It is a 6 times. 1, 2, 3, 4, 5 and 6. Then it is the probability of x is equal to 2. It is 6 upon 16. And here number of x is equal to 3. X is equal to 3. It is a 4 times. Therefore it is the probability of x is equal to 3. It is 4 by 16. Here we write number of x is equal to 3. It is a 4. Therefore it is the probability of x is equal to 3. It is a 4 by 16. And now last, x is equal to 4. Number of x is equal to 4. It is a 1 time. Therefore probability of x is equal to 4. It is 1 by 16. It is a probability distribution. Now we write the probability distribution table. Therefore probability distribution of random variable x is, see carefully this. Here it is x. The values of x, it is a 0, 1, 2, 3 and it is 4. Now here it is a probability of x. Here when 0, it is a probability 1 by 16. Then it is a 4 by 16, 6 by 16, 4 by 16, it is 1 by 16. It is a probability distribution. Okay. But here the again extra question is asked, write the formula for this probability distribution. Now here in the probability the 16 is a common in all things. Now here it is a, in the numerator there is 1, 4, 6, 4 and it is 1. Now there are the 4 coins are tossed. Therefore it is a combination with 4. Okay. Then formula for PMF of x is, see carefully, here probability of x is equal to x. Here it is a 4cx upon 16, where x is equal to 0, 1, 2, 3 or 4. Okay, here 4cx, it is a combination, it is a formula. When x is equal to 0, when x is equal to 0, it is a 4c0, that means 1, it is 1 by 16. When x is equal to 1, it is a 4c1, that means 4 upon 16, it is 4 upon 16. When x is equal to 2, see carefully, x is equal to 2, is 4c2, that means 4 into 3 upon 2 into 1, 4 into 3 upon 2 into 1, it is a combination, and that is a 6. Therefore it is, then when x is equal to 3, it is 4c3, that is 4c3. It is 4 into 3 into 2 upon 3 into 2 into 1, again 3 2 3 2, it is 4, 4c3. When x is equal to 3, it is a 4 upon 16 and it is a last 4c4, it is 1, it is 1 by 16, it is a formula, and here 0 otherwise. Okay, here see carefully this. Here the probability distribution we are already write in a exercise 7.1. okay, here only ask, here there is a extra question, that is a formula, write the formula for this PMF, and it is a formula for the PMF. Okay, see carefully. Now we see the next example. Now example number 7, find the probability distribution of number of success in a 2 tosses of a die. Where success is defined as, here the first question, the number is greater than 4, okay, and 6 appear on at least one die. It is the second example, and here the both examples are already done in our exercise 7.1. okay, here the 6 appear in at least one die. This example we learn in mean, variance and standard deviation, and it is a probability distribution, first example. Okay, I think our lecture number 7 and 9. Okay, the first example in a lecture number 7 and second example is a lecture in the lecture number 9. Okay, now we see here it is a when a die is tossed 2 times, then there are the 36 possibilities. Okay, here these are the 36 possibilities. Now the first question here, let random variable x is number greater than 4. Number greater than 4. Okay, here see carefully, number greater than 4, that means 5 and 6. Now in the first outcome it is a random variable, that means random variable is a real number associated with each outcome of a sample space. Here it is a 36 outcome. First outcome 1, 1, there is a no 5 or 6, that means here it is a 0. A number greater than 4, here 0. Number greater than 4, it is 0, 0. Number greater than 4, here also 0. But here number greater than 4, here it is a 1. Number is a greater than 4, that is 5. Here it is a 1, 1, 1. Here it is 1, 1, 1, 1, 1, 1. But here 5, 5, there are the 2 numbers greater than 4. Here 2 numbers greater than 4. 2 numbers, and here it is a 2 numbers are greater than 4. That means random variable x takes values 0, 1 or 2. Okay, and now here see carefully this, the random variable takes value 2 in these 4 outcomes here, and here random variable takes value 1 in these 4, sorry it is in this 8 and this 8. Okay, here see carefully this. See carefully here, when x is equal to 2, therefore the number of x is equal to 2, it is a 4. When x is equal to 1, x means the number greater than 4. Number greater than 4, when x is equal to 1, it is 8 plus 8, it is 16. And when x is equal to 0, here again 1, 2, 3, 4, and it is 4. There are the again 16, 16, 16, and it is a 4. Okay, now therefore the number when x is equal to 0, it is a 16, and therefore probability of x is equal to 0, it is a 16 by 36, and 16 by 36 again, right, it is a 4 by 9. Then number of x is equal to 1, again it is 16. Probability of x is equal to 1, it is 16 by 36, it is a 4 by 9. And last, number of x is equal to 2, it is a 4. Okay, and therefore probability of x is equal to 2, it is a 4 by 36, it is 1 by 9. Okay, here, and then we write the probability distribution. Of random variable x, and here x is a number greater than 4, then it is a x, it is a 0, 1 and it is 2. Then probability of x, it is 4 by 9, 4 by 9 and 1 by 9. Okay, now see carefully this. Now we see the next example, that is a 6 appear on at least one die. Here it is a probability distribution of number greater than 4. Now the second example is 6 appear on at least one die. Therefore let the x is a number of 6s. Number of 6s appear on at least one die. Okay, here we want to count the number of 6s. Here in the first outcome there are 0, 6. Okay, here it is a 0, 6, 0, 0, 0, 0, but here it is a 1, 6. Okay, 1, 1, 1, 1, 1 and here 2. That means the random variable takes values 0, 1 and 2. Then 1, 6, here see carefully this. In the 5 outcome and here it is 1, 6 and here. Okay, and in this last outcome there are the 2 6s. Okay. Now random variable x takes values 0, 1 and 2. Okay, therefore when x is equal to 2, the number of x is equal to 2, it is a 1. When x is equal to 1, the number of x is equal to 1 is equal to 1, 2, 3, 4, 5 and this 5, 10. Okay, it is 1 and it is 10, 11. And then the remaining 25, here it is a number of x is equal to 0. It is a 25. Therefore, number of x is equal to 0, it is a 25. And therefore, probability of x is equal to 0. It is a 25 by 36. Number of x is equal to 1, it is a 10. Therefore, the probability of x is equal to 1, it is 10 by 36. Number of x is equal to 2, it is 1. Probability of x is equal to 2, it is 1 by 36. Okay, and therefore the probability distribution. Of random variable x is x, it is 0, 1 and 2. Then probability of x, it is 25 by 36, 10 by 36 and it is 1 by 36. Okay, it is a probability distribution. Okay, now it is example number 7. Now the next example. Now here it is the example number 8. The given probability distribution is this, and then find first the value of k, then the probability x greater than 6, and third example it is a probability of 0 less than x less than 3. Here this type of example in exercise 7.1 in our video lecture number 7 we have already done, but difference in these two examples. Okay, here the find the value of k, it is the same, but refer for these two examples, refer the lecture number 7. Okay, here see carefully this. Now we solve the example number 9. Here it is a cumulative distribution function given that the CDF, and we want to find the PMF. Okay, in the last lecture given PMF and we want to find the CDF, but here the CDF is given. First we want to find the PMF, and then from the PMF we solve these two questions. Okay, here CDF, the concept of the CDF in our lecture number 3. First watch carefully the lecture number 3 of this chapter. Okay, now here the given CDF, now we want to find the probability mass function of the solution of question number 9. Then PMF of, it is a random variable x is, see carefully, we want to, here it is a f of minus 3, it is f of minus 2, it is f of minus 1, f of 0, f of 1, f of 2, f of 3, and it is f of 4. But we want to find the probability of minus 3, probability of minus 2, probability of minus 1, probability of 0. Here it is f of x, we want to find the p of x. Therefore first it is a probability of x is equal to minus 3 is equal to f of x is equal to minus 3, and it is 0.1. Here it is a first probability, we get 0.1. Then probability of x is equal to minus 2, it is f of x is equal to minus 2 minus f of x is equal to minus 3. F of minus 2 minus f of minus 3, it is f of minus 2 and it is f of minus 3. F of minus 2 minus f of 3. Therefore we get here 0.3 minus 0.1, and that is 0.2. Here it is a probability of x is equal to minus 2. Then probability of x is equal to minus 1, it is f of x is equal to minus 1 minus f of x is equal to minus 2. See carefully, we want to find the probability of minus 1. Then f of minus 1 minus f of minus 2. Then it is 0.5 minus 0.3. It is 0.2. 0.5 minus 0.3. Now the probability of x is equal to 0. Okay, see carefully, it is f of 0 minus f of minus 1, and then it is 0.65 minus 0.5, and that is 0.15. Then probability of x is equal to 1, it is f of 1 minus f of 0, and f of 1, it is a 0.75. 0.75 minus 0.65, and it is 0.10. Okay, then probability of x is equal to 2, it is f of 2 minus f of 1, and f of 2, here it is 0.85 minus 0.75, again it is a 0.1. Probability of x is equal to 3, it is f of 3 minus f of 2, and f of 3 0.9 minus 0.85, and that is 0.05. It is a subtraction. Last, probability of x is equal to 4, it is f of 4 minus f of 3, then 1 minus 0.9, it is 0.1. Here these are the all probabilities. Here it is a cumulative distribution function. Now we write the probability mass function. Therefore PMF of random variable x is here random variable x takes values -3, -2, -1, 0, 1, 2, 3, and it is a 4. Now here it is a probability of x. Given f of x, we find the probability of x. When x is equal to -3, probability is 0.1. When x is equal to 2, it is a 0.2. When x is equal to -1, it is a 0.2. When x is equal to 0, it is a 0.15, 0.1, 0.1, it is a 0.05, and last 0.1. It is a probability distribution, that is a probability mass function of random variable x. Okay, here it is the first question. Now again the two questions are asked. Find the probability of this, probability of -1 less than x less than 2, and it is a probability of x less than or equal to 3 divided by it is a x greater than 0. Okay, here it is a divided by, that means it is a conditional probability. Okay, here we discuss this. Now the first question is probability of -1 less than x less than 2. Here -1 less than or equal to x less than or equal to 2, that means x in between -1 and 2, it is -1, 0, 1 and 2. Therefore it is probability of -1 plus probability of 0 plus probability of 1 and plus probability of 2. See carefully this, -1 to 2, -1, 0, 1 and 2. Then the addition of all this, it is a 0.2 plus 0.15 plus 0.1 and plus 0.1, and then it is the addition. Here it is 5, and then 1 plus 1, 2, 3, it is 5. Here it is a answer of first question. Now the second, okay, see carefully, it is a probability of x less than or equal to 3 divided by it is a x greater than 0. Here it is a divided by, but here it is not division. Okay, here it is a slash. Notation for the slash we use for the division, but here it is a probability. Here it used for the conditional probability. Here conditional probability of A by B. Here the probability of event A when B is already given, it is a conditional probability, and formula is probability of A intersection B upon probability of B. Okay, remember this, it is a formula for the conditional probability of A by B. Now here it is A and here it is B. Okay, now from this it is a conditional probability of A by B. Okay, it is probability of event A when B is already given. Here this can be written as probability of x less than or equal to 3 intersection x greater than 0 divided by probability of x greater than 0. Okay, now see carefully, we write this here. It is a probability of this x less than or equal to 3 intersection x greater than 0. Here the probability, now first it is x less than or equal to 3 means the values of the x less than or equal to 3, it is a 3 less than or equal to 3, that means -3, -2, -1, 0, 1, 2 and 3. And the second it is x greater than 0. X greater than 0 means 1, 2, 3 and 4. 1, 2, 3 and 4. Now here we want to write the common numbers, that is the intersection. Here 1, 2 and 3. 1, 2 and 3 are the common in the, we write in the numerator. Therefore here it is a probability of x is equal to 1 plus probability of x is equal to 2 plus probability of x is equal to 3, and in the denominator probability of x greater than 0. Here it is x greater than 0. Probability of x is equal to 1, 2, 3 and plus probability of x is equal to 4. Okay. Now put the values of probability and calculate this. Here probability of 1, it is a 0.1 plus 0.1 plus 0.05 upon here 0.1 plus 0.1 plus 0.05 plus 0.1. Okay, here, and now calculate this. Here it is a 0.25 upon 0.35. Okay, it is addition of this, that is 25 upon 35, and 25 upon 35, it is a 5 by 7. Okay, here 5 by 7, it is a probability of this. Here it is a conditional probability. Here first we find the intersection. Here it is a intersection 1, 2 and 3, x less than or equal to 3 and x greater than 0, and it is a intersection, it is 1, 2 and 3, and x greater than 0, it is 1, 2, 3 and 4. Okay, here see carefully this.